Today, let's go over a medium question that I just solved on my own a second ago. This one is very challenging, but I'm going to try to explain it. Basically, you need to sum the differences of the same index, absolute difference. So if you have 1 that maps to index 0, 2, and 3, and you need to do, so the current index is 0, so you're going to do 2 minus 0 plus 3 minus 0, and that's going to give you the difference in absolute difference. So the difference in all the indices. So if you know that, then this one's going to be 0, for example, because this is the only 2, this is the only 3. So let's go ahead and create a dictionary to map the values to the indices. Let's call this D equals to default dict of list. It's already going to be in order because we're going to go from left to right. So the indices are already going to be in order. In enumerate nums, D of n dot append I. And then PD is going to be a dictionary because we're going to have to accumulate these for binary search later. So for K and D, PD of K dot append, or just equal to list of itertools dot accumulate DK, right? So for example, if we have our indices of 0, 2, 3, the PD is just going to do 0, 2, 5. Okay, it's for each element. And then now we have to run our binary search, where essentially we are going to do left. We're going to run a binary search, and we're going to find, just like with the last problem, how many elements are less than and how many elements are greater than. So for example, let's say left is going to be bisect of left inside of D of n. I, we're working with the indices. Sec right inside of D of n and I, because, for example, if we have 0, 2, 3, and the current index is 0, then we know that if we create a list of this, like this, we can do the sum of this minus this times the length of this, because this is always going to be bigger than this. And then this times the length of this minus the sum of this, same thing as before. So then we're just going to do, if left is bigger than 0, that means there's something, the left list has elements in it. So we're going to say low equals to high equals to, the low is just going to be equal to the, so current is going to be PD of n is going to be PD of left minus 1, right? That's just the current prefix sum to 5. If the prefix sum of this is just 5 minus 0 is just 5. So the high is just going to be the current length. So it's just going to be the length of, or just going to be left times I, because that's, left is up to this point. And then now is 0. Now we're going to add low plus high. If right is less than length of dk, same thing, low equals to this, high equals to this. So we're just going to work with our prefix sums. The low is going to be the current index times, so the current index times the length of dk, and then the high is just going to be the sum of, or instead of n, we're going to get this in O of 1 using cur of, if right is less than or equal to 0, high is going to be equal to current of -1. Otherwise, high is current of -1 minus current of right minus 1. And then now plus equals to low minus high. Result dot append low, or now. Result is this. And then return result at the end. Okay. what is PD? It's current, which is the prefix sum. That's not right. So current is PD of n. This is just the accumulated list. So if left is less than or equal to 0, low equals cur left minus 1, else low equals 2. Yeah, it's supposed to be just current. So it's supposed to be, I'm not sure why this is not working. Total sum minus current of right minus 1, yep. Less than the length of decay. Length of decay minus right. Because length of decay, so let's call this curlen is length of decay. Curlen minus right. Okay, guess not. So because the low is just supposed to be the current I times, yeah, the length of right, which is just going to be the total length minus right. Minus 1 maybe? So what we were trying to do is just do left is going to be nums of everything, or oh wait, length of decay, it's supposed to be current length minus right. Low is supposed to be, this is a pain in the ass, but let's do this. Low is I times current length minus right. So current length, yeah, length of decay minus right. And the current index. Let's just do this the simpler way. So LL is going to be what? Is going to be nums of everything up to left. Right is nums of right to the end. Low is just sum of left. High is just yes. And then the low here and then high here is just sum of right. Low is just I times length of right. Length of left. If left, if right. I don't know why this is wrong. Let's print left, right, and I. What? PD of K, same as PD of N. Bisect right, D of N, I. Oh, low plus high. What the? Length of LL times I. Yeah, sum of LL. Oh, high minus low, sorry. High minus low. high minus low. Yep, that's supposed to be right. I don't know why this is wrong. Wait a second. Print D. So that does not look right. Let's see. Inside of D of N, yep, I. Let's get rid of all this for now. Right to the end. Bisect right. DNI. Yes, I is this. Why are we showing this though? I do not understand at all. Print left and right and DN. So up to left, why are we showing this? Why? Right is right to the end. No. This is fine. So left is nums of everything. Oh, D of N of everything up to left. And then right is D of N right to the end. So now if, just call this cur is dn. So now we can say if left is bigger than 0, then low, high, now plus equals to high minus low. Low is just sum of left. High is just going to be I times left. If right is less than length of D of N, then low is going to be curlen is length of D of N, curlen minus right times I. Right, so just high is going to be sum of right, now plus equals to high minus low, result.append now. Okay, length of current, just curlen, sum of right. Why is this not? Cannot access local variable now. Cannot access local variable now. What are you talking about? Oh, I forgot to define now. So that should give us the correct answer, but time limit exceeded. So let's go ahead and this is where we want to use the prefix sum. So cur sum is going to be PD of n because that's the accumulated list. So 1, 2, 5 for this. And then cur sum of left minus 1. And here we can just do cur length. We can do if right is less than or equal to 0, then high is just going to be cur sum of -1. Else high is just going to be cur sum of -1 minus cur sum of right minus 1. Eliminating the need for this. Hopefully. Okay, cool. There we go. So passes all test cases. I'm not going to lie. I came up with this by myself, but it took me a very long time. And then this was the breaker because if you did this with n again, that would be time limit exceeded. It's pretty frustrating, but hopefully this video was at least somewhat helpful. And thank you for watching and stay tuned for more.